All right, let's talk about something that puzzles a ton of parents, teachers, and of course, students. You've probably seen it. A child who has a hard time with reading often has a hard time with math, too. It can feel like this double trouble situation. But what if it's not just a coincidence? What if these two problems are actually connected on a much deeper level? Today, we're going to unpack the science behind why these two learning challenges so often show up together.
So here it is, the central mystery we're trying to solve. Why does this happen? It's definitely not just random chance. In the world of education and science, they actually have a name for this. It's called comorbidity. And, figuring out why this happens is a huge puzzle for researchers. I mean, they seem like totally separate skills, right? Reading is words, math is numbers. So why do they go hand in hand so often?
And when I say often, I mean really often. The overlap is massive. Studies have found that anywhere from 11% to a pretty staggering 70% of kids who have a learning difficulty in one of these areas also have it in the other. Now that's a huge range, which tells us this whole thing is pretty complex. But the main takeaway is crystal clear. This is a super common challenge. So what is actually going on under the hood?
To get to the bottom of this, scientists have basically come up with two major competing theories. You can think of it like a scientific showdown, a battle to explain this whole double trouble phenomenon. And each theory has a totally different take on how these learning deficits really work together.
Okay, so first up in the ring is the multi-deficit model. This idea suggests that when a kid struggles with both reading and math, it's not actually one single giant problem. Instead, it's more like a mix of different issues. You've got some problems that are just about reading, some that are just about math, and then you have these more general cognitive skills, like working memory, that can affect both.
Let's make this way simpler with some deficit math. So, one part of this theory says the problems are additive. It's as simple as it sounds. 1 plus 1 equals 2. You have one distinct reading issue, you add on one distinct math issue, and the combined problem is basically just the sum of its parts. Nothing more, nothing less.
But the multi-deficit model has another trick up its sleeve. It also allows for under-additivity. In this case, our deficit math looks more like 1 plus 1 equals, say, 1.5. So why would that happen? Well, it's when there are shared risk factors, like a weak working memory, that are causing trouble in both reading and math. The problems overlap, so the combined difficulty is actually a bit less severe than you'd expect if you just added them together.
Now for the challenger. This is the three independent disorders model. This theory makes a pretty bold claim. It says that having both reading and math difficulties isn't just a combination of the two. Nope. It suggests this combined condition is its own unique learning disorder, completely separate from having only a reading problem or only a math problem.
The deficit math for this theory is where things get really interesting. It's more like 1 plus 1 equals 3. Scientists call this over-additivity. The idea is that when you put these two difficulties together, they don't just add up, they interact and create something new, something qualitatively different, and often something much more severe than just the sum of its parts. So let's put it all together. The whole scientific debate really boils down to this simple math. Does 1 plus 1 equal 2? Or maybe 1.5? If so, that's a win for the multi-deficit model. Or does 1 plus 1 equal 3, creating a whole new kind of problem? Well, that would mean the three independent disorders model is the right one.
So which is it? How do we find out the answer? Well, to settle this debate once and for all, scientists decided to go big. They launched a massive investigation designed to figure this out.
And they used a really powerful scientific tool called a meta-analysis. The best way to think about this is as a super study. Instead of doing one new experiment, researchers gather up all the best studies that have already been done on a topic, and then they use some serious statistical power to combine all of the results. This gives you a much bigger, way more reliable picture of what's really happening. And when I say this one was big, I mean it. The research team pulled together the findings from 74 different high-quality scientific studies. We're talking decades of research, all brought together to create one unified picture. And get this. In total,
They analyzed data from over 11,500 children. I mean, wow. By looking at a data set that massive, they could finally get the statistical power they needed to see which of these two theories really stood up to the evidence. And that brings us to the big reveal, the moment of truth. After crunching all those numbers and analyzing all that data, what did this massive super study actually find? Which theory won the showdown?
And here's the answer, laid out so clearly. For the core reading skills and for the core math skills, the researchers found really clear evidence of additivity. That's our 1 + 1 = 2 scenario. The problems just add up. But, and this is the key part, for a group of general brain skills we call executive functions, things like memory and focus, they found under-additivity. That's our 1 + 1 = 1.5 scenario, which strongly suggests there's an overlap.
The researchers themselves put it perfectly. They said that for the most part, the struggles of a child with both difficulties look like the sum of the struggles from each difficulty alone. It's an additive profile. But, and this is a really important but, there's a fascinating and crucial exception to that rule.
Right, this is where that crucial little nuance comes in. While the big picture was additive, the researchers found that for some very specific core executive functions, the deficits were under-additive. They overlapped. And what were these skills? Things like inhibition, that's your ability to control impulses, shifting, which is moving between different tasks, and updating, which is kind of like refreshing what's on your mental desktop. This is huge evidence for that shared risk factor idea.
So there you have it. We have a clear winner. The evidence from this massive study overwhelmingly points to the multi-deficit model. The challenges these kids face aren't some new mysterious third disorder. No, it looks like they're a combination of separate problems that add up, plus some shared underlying weaknesses in those general brain skills that cause overlap.
Okay, so this is all really fascinating science, right? But what does it actually mean for helping kids in the real world? How does this change things? Well, it turns out this gives us a much smarter way to think about providing support.
The study's findings really point to a clear three-part strategy for us. Number one, we absolutely have to recognize that deep link between language and math. Number two, we should focus on supporting those general executive functions, the skills that help with both subjects. And number three, it's so important to screen for other related issues that might be playing a role.
So here are the big takeaways for parents and for teachers. First, realize that those core language skills, like phonological processing, aren't just a risk factor for reading trouble. They're a risk factor for math trouble, too. That means supporting those general-purpose executive functions, things like working memory, can give kids a boost across the board in both subjects. The study also reminds us how important it is to screen for co-occurring things like ADHD, which is often an underlying factor. And finally, and maybe most importantly, because every kid's mix of challenges is unique, individualized support is absolutely essential.
And that really leaves us with this final big picture question. Knowing just how interconnected these difficulties are, how can we start to move beyond just labeling a kid with a reading problem or a math problem and start building support systems that see the whole child? This research is a powerful reminder that sometimes the best path to helping a child with math might actually run right through their language skills and their ability to focus, proving that in learning, everything is truly connected.